The first example from the geometry ACT practice says hexagon A, B, C, D, E, F shown below was drawn on a grid with unit squares. Each vertex is at the intersection of two grid lines. What is the area of the hexagon in square units? One thing to notice is that the answers for this problem are set up in order from least to greatest, and that continues to happen on the ACT. So the best option is to start somewhere in the middle to see if this answer would be correct, and then either work your way down if it needs to be smaller or up if it needs to be bigger. Really, for this problem, you can kind of just look at the boxes and think, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 18 full boxes for sure. So can't be the answer 18. Then I have, looks like a half box, and then these two together might give us one more. So looks like it's going to be 20. Definitely can't be 22, definitely can't be 25. Can't be 19 because this right here would have given me 19, so 20 is the best option. Example 2 says, in the figure below, A, D, B, and G are collinear. If you forget, collinear, linear means line. Co means together, so these are together on a line. If angle CAD measures 76 degrees, BCD measures 47 degrees, and CBG measures 140 degrees. What is the degree measure of angle ACD? So remembering a few things from geometry, straight lines like this one right here add up to be 180. So if part of that is 140, the other part has to be 40 because again, has to add up to be 180. Another thing to remember from geometry, triangles add up to be 180. So I have 40 plus 47, that's 87. I subtract that from 180, I get 93. This angle here is 93. Still working my way over. Again, I have a straight line here. It has to add up to be 180. That's going to get me 87. So this piece right here is 87. And then lastly, we have one last triangle. So if I add those values, 76 plus 87, I get 163. Subtract from 180, 17. On this next problem, it says the parallel sides of the isosceles trapezoid shown below are 10 feet long and 16 feet long, respectively. What is the distance in feet between the two sides? Now, the figure's already labeled, so we just really are looking at this. What is the distance in feet between these two sides? So we're wanting to know what is this distance right here. So, couple things we know. We know that this piece here is 10, which would mean this part here is also 10. If the entire thing on the bottom is 16, that means I have a section left here and here. So, 16 minus 10 is 6. That is split between those two little parts, so that gives me 3 on each side. Last, I have this triangle right here. It's a right triangle. If I want to find a missing side of a right triangle, we use Pythagorean theorem, which hopefully you remember is a squared plus b squared equals c squared. The side that's c is across from the right angle. A and B, you just fill in. They don't really matter. C is the only one that has to be in a certain spot. If you square both of those, you get 9 and 25. Subtracting 9 from both sides, you get 16. Take the square root, you get 4. The next example says, in the 8-sided figure below, adjacent sides meet at right angles and the lengths given are in meters. What's the perimeter of the figure? So there's a few things you can do here. So right here, I'm seeing that this entire thing is this section that's 12 and this section that's 8. So all together, that would be 20. On this other side over here, I have the exact same height. So this piece and this piece added together is also 20. Really similar on the bottom. The entire bottom is 20. And if you look, I have a piece here, a piece here, and a piece here that make up the exact same length. So that top section added all together, it's also 20. And so when I add those together, I have 20 on the left, 20 on the top, 20 on the right, 20 on the bottom. In total, that gets me 80. There's a lot going on in this one. There's a lot to read. So just a couple key things is you don't want to waste a ton of time reading on the ACT, especially if you're given a figure. So just skimming really quickly, I'm seeing that these lines are parallel. That might be important. All of the diagram's already filled in for us. So then I'm just going to read the question, and it says, how many of the angles formed by rays LMT and U have measures of 50 degrees? So I'm just going to start filling in missing angles that I know. So one thing from geometry, if you forget, is if you have angles that are kind of formed by two intersecting lines, if they're across from each other like this, they're called vertical angles and they're the exact same. So I'm seeing some vertical angles like here and here. So this would be 130. I'm seeing vertical angles here and here, so this would be 80. Again, remember that if you have a straight line, it adds up to be 180. And so right here's a straight line. So 180 minus 130 is 50. So I have 50 degrees here. These two are vertical, so this is 50 degrees. I have a triangle. I know triangles add up to be 180, so I have 80 plus 50 is 130. 180 minus 130 is 50, so I have another 50-degree angle here. These two are vertical, so I have another 50-degree angle. I know that this is a straight line, so this would be 130, and this would be 130. There's also a type of angle pair in geometry when you have two parallel lines. If you have angles on the inside and the same side, so like this angle and this angle, they add up to be 180. So if you are looking at this angle right here and this angle here are on the same side on the inside, so they're going to add up to be 180, which means this is 50. Here's a straight line, has to add up to be 180. I have 80 and 50, that's 130. 180 minus 130 is 50, so here's another 50. I see some more vertical angles, so if you look here and here, these are vertical, so this is 50. If you look here and here, vertical angles, so this is 50. And then it looks like I have every angle filled in, so I just need to go back through and figure out how many 50s I have. So 1, 2, 3, 4, 5, 6, 7, 8. For the next one, it says the edges of a cube are each 3 inches long. What is the surface area in square inches of this cube? So if you think about a cube, it is a 3D square. So if you think about surface area is the area on the outside of the shape. So think of like a tissue box. I want to know the area of all of the outside. So think about it. I have this front face here. So this is just a square. This square is 3 by 3. If I want to find this area only, I'm going to do base times height, which is 9. How many of those squares are on a cube? So think about it. Front. There's a back. There's a left side. There's a right side. There's a top. There's a bottom. So I have 6 of these squares exactly. So that would just be 9 times 6. 9 times 6 is 54. On this next problem, again, it's really wordy, but you're given a diagram. So just look at the diagram and then go find the question. So the diagram is shown. Then it says, to the nearest cubic foot, what is the volume that will be in the pool when it is filled with water to a depth of 5 feet? So although it gives me a picture, it only wants me to tell how much volume there will be when the height is 5. So I don't really care about this 6. I want the height to be 5. If you forget, the volume of a cylinder is pi r squared h. So radius is the height. R is the radius, H is the height. We fill all that in right here, 24. 24 is not a radius, it's a diameter. Remember, diameter goes all the way across a circle. Radius is only half. So I need to divide this by 2. I get that my radius is 12. The height they want me to use is 5. If I type that directly into my calculator, I get 2261.9. Remember, it says nearest foot, and so the closest answer would be H. So this problem is an extension of the last one. So they give you a diagram, and I also filled in that the radius is 12 because we figured that out in the last problem. This one talks about them making a cover for a pool. The cover will rest on the top of the pool and will include a wedge-shaped flap that forms a 45-degree angle at the center of the cover as shown in the figure. A zipper will go along one side of the wedge-shaped flap and around the arc. Which of the following is the closest to the length in feet of the zipper? So we know that this part of the zipper here is going to be 12. And we just need to find this section here. So to find that section, I need to know the arc length. And arc length is going to be degrees over 360 because there's 360 degrees in a circle times the circumference, which is 2 pi r. So our degrees is 45 over 360 times 2 pi, radius is 12. You type this into a calculator. Once you type it in, you should get about 9.4. Remember, I need to add on that 12, and so I'm going to get about 21.4. And it says which one's the closest length, and so the closest length would be 22.